Here we go. So, this is what we're working on. We're working on our game, and like I said, hopefully we can we can finish it. So, currently, let's see, what do we have in this class? We have badgers that run.
I think we just started the arrow part.
Yeah, so this is all you guys should have. And we hadn't started the arrows because once you start it, it's kind of difficult to stop midway. So, what we're going to do is we're going to start the arrows.
Are you going to share your screen?
I was waiting for you to ask that.
Okay.
How do I share it? I have to open. There we go. Okay, so right after we don't want anything under update, right? Our pygame.display update, that has to be after what? What type of command? Does anyone remember? Josh?
What?
Yep, we can't have anything blitted after display.update because otherwise we won't see it. So do we need to blit arrows on screen for them to be seen? So it needs to be above that. I'm gonna do this little bit of code. Hang on, what have we done? So we have arrow, and we have okay. So yeah, we just need to start blitting everything on screen. So underneath screen.blit player X, player Y. I have explained that before. I'm not explaining it again.
Okay.
It's to help you with other things later. So, what we're going to do is we're going to do 4. We need another for loop. And slide this over. How did I do it over here? Actually, let's do this. So you guys can ignore everything in here, and we're going to do this right above our bad guys. For you, it's the same thing. It's just I have all of this in between it, so it's easier for me to put it down here. So we're going to do for arrow in quiver. What happens every time we click our mouse button? Technically, no. Well, yes, technically, yes, that's what we see on screen. But in our code, what happens?
Arrow goes to where we are.
No. Say that again? No. Ezra?
Doesn't it do that like math thing? I don't remember what it's called, but like it does like the triangle and
What it does is it puts coordinates in a list. All right, so every time we click, we're doing. You guys all said various parts of the truth. It does send an arrow to the coordinates. It does do a bunch of math, and it does, we do shoot our arrows. But in our code, what it does is it does math and it gives. Do you guys remember the 3 things it puts in the list for an arrow?
X, Y position.
X, Y.
You have X, Y, and
Direction.
an angle. But angle is first, then X, and then Y.
They're basically giving it.
Mr. Salter,
Yes?
have we added anything today yet?
No.
Okay, sorry.
Oh my, vectors.
Yeah, so again, I don't know arctangent, nor do I pretend to be. This is what you need, and that works. So what we're now doing is we are cycling through that list that we create and add an arrow to every time we click. So that's what this for loop is doing. We have a for loop down here that's going through our bad guys. And we also have a loop that's going through our arrows. Does that make sense to everyone? Yes, no, okay.
You make the code like a little bigger.
Control plus doesn't work. Is that big enough, or do you want it a little bigger? Okay, so for arrow in quiver. Now this next part, in order, how we move our characters, we move our badger how?
Wait, you mean that bunny thing?
We move the badger across screen by doing what?
Refreshing, blitting, right?
We blit it, but how do we move, how do we change the coordinates, Ezra?
Well, we re-lit it to that space, and then don't we have to delete the previous image?
We don't delete the previous image.
We add to the X and Y.
Well, we subtract from the X, and that's what this line does, and that scoots it this way to the left across the screen. But yes, we add or subtract to the X and Y values in order to move things across the screen. So we subtract X, and then we put the image at that new location. We subtract more from X, we put the image there, so it slowly moves across the screen. Now, if we have a arrow moving across the screen, we no longer have something that's just moving this direction. That's moving that direction, right? It could be moving that direction. It could be moving like this. It could be moving like that. It could move like that. It could move like that, right? So it's not necessarily always going to be -7. It could be +6 to the X and +4 to the Y. Does that make sense?
Mm-hmm.
Because it has to follow along this trajectory.
So you have to do a little bit of trigonometry.
Yes, that's what I'm getting to. Again, I'm giving you that information. You guys don't have to understand sine. I don't remember what sine and cos. It takes me a little bit, but I can remember what sine, cosine, and tangent do in regards to a triangle. I don't know it off the top of my head. If you said sine of pi, I'd be like, pi? Pumpkin? So I'm not expecting you guys won't be quizzed on which one do you use for sine or cosine.
Thank you.
But just know that we can't just have a flat -7 to have it move anywhere across the screen. It has to follow this blue, the hypotenuse. I do remember that term. That's this right here, and follow the path from our bunny to our mouse. Okay? So we do that. This is our angle right here. So what we end up doing is we find the cosine and the sine of that angle, and we add those values to the X and Y. Okay? Does that make sense? Again, I'm not expecting you guys to understand, oh, yes, sine of this is going, it's just basic sine, cosine, tangent. We use that to get a value, and then that is the speed, and that's how much we change our arrow. Okay? Okay. So now what we're going to do is for arrow and quiver, we have our velocity X and our velocity Y. So again, this is just how much do we add or subtract to the Y, and how much do we add and subtract to the X. Because if we are going, if our arrow is going straight up, say this is our bunny is right here, and he shoots straight up, how much are we subtracting from the X? 0, and we're only subtracting from the Y. Whereas if he shoots directly that way, are we subtracting or adding anything to the Y? No, it's all in the X. So that's why we have velocity X and velocity Y, because you have to change both of those values in order for it to move anything, for it to move diagonally. Because if we only change X, then our arrows can only move this way. And if we only change Y, our arrows will only move up and down. So we have to change a little bit of X and a little bit of Y in order for it to go this direction. Yes. Well, sine and cosine, and those of you who know trigonometry, sine or cosine of any angle is always between -1 and 1. I think, I don't know. I very well could be wrong. But what we end up doing is we multiply this value by 10, and this is our speed. That'll make sense in just a second. Okay?
Mr. Stolter,
Yep.
why did the Python programmer guy get rejected by the Java programmer girl?
You do know this
Because
is
he was
going
not
on.
her type. Get it?
I do, but you do realize this is going on YouTube, right?
What?
Every video I record goes on YouTube, and I'm recording
There's
this.
like 200 subscribers.
Yeah,
I was just trying to make you laugh.
I know. I appreciate it. Just during a break. I'll take any joke during the break, but you just interrupted my flow. Now I gotta start all over.
Oh no.
Is the video going on your YouTube too? Like the that
This camera, no. That's only for Mikey.
Okay.
This
good.
one from my Surface is, yeah. The only thing that goes on YouTube is my screen and my face.
Wait, can they hear us?
They can hear you, yes.
Oh, that's concerning.
Well, just don't say anything bad and you're fine.
Oh,
All right, so what we're going to do is we got to do math.cosine and math.sine. And what is the index of the arrow angle? What?
Wait, what?
So our arrow consists of 3 elements. An angle, an x, and a y.
Cosine is usually in the x direction,
Yes,
but sometimes it's not.
but it is. So what index of arrow do we need to put in here? Because we're finding the cosine of the angle.
That'll be the 0, right?
Yep, so we have arrow 0. Same thing here, arrow bracket 0. And then we times it by 10. 10.
Because that's the speed.
Yep.
Why do you want this
Say that again.
Why do we want the speed of the arrow to be related to the angle that it shoots at?
So if you do cosine of the angle, that's going to give you 0.5. We times that by 5, and it's going to move in the x direction, 5 pixels. And then if we do sine of the angle and it gives us 1, that's going to have us, which I don't think it would because sine and cosine together have to equal 1, I think. Then you have sine of the angle, that'll give you 1. You times that by 10, that gives you 10. So then it moves over 5 pixels and then down 10, and it travels in that line.
Okay.
This is what, it'll make sense once you see it in action, I think. This right here is the speed of the arrow. So if you want your arrow speed to change, make this a variable, and you can actually change it at will. Yes, Ezra?
So, how does multiplying it by 10 change the speed of it?
It's not changing the speed of it. This right here, 10 is the speed. 10 pixels. What this does is, all right, let me do a new drawing. Yes. No. Okay. So if this is our bunny, and this is our arrow, and I'm not going to draw the whole bunny. Oops, I don't want that open. So that's our angle, right? So our code finds this angle by having this x this X and Y position of our bunny and this X and Y position of our mouse. Does everyone understand that? So it finds this angle. Okay? If we are going to shoot an arrow along this trajectory, it needs to change both the X and the Y. Now in this trajectory, the X and Y position of our arrow, in this, is it an even, it's going to scoot over 5 pixels and then down 5 pixels? No. So it has to change, it changes the X a little bit and the Y a little bit, but it's not the exact same. So it changes the X more than it does the Y. Then it changes the X more than the Y.
But it's not visible. Like you can't see it.
Right, all we're going to see is we're just going to see an arrow following along this line. But it's blitting the arrow. Now, our image of the arrow is this, right? What we end up doing is we rotate it this same angle. So we take this image and we rotate it however much this angle is. So our arrow will actually will look like that. And so we're blitting the top left. Remember, everything we blit is the top left of the image. The top left corner of the image gets blitted at those coordinates. So technically, it's blitting like this. So the top left is following this line. And this line is cosine of x times 10. And we add this to the arrow bracket 1. Because our arrow, again, is an angle, an x, and a y. So this is the angle, the x position, and the y position. So what we're doing is we are adding a number, and I'm going to make up a number. Let's call this angle 60. Who can give me the sine of 60? 1/2. So sine of 60 is 1/2. That equals 0.5. What's the cosine of 60? 3 over 2? Square root of 3 over 2.
Yeah, I think, yeah.
What does that equal? Like, give me a decimal. 1.4? 1.14? Okay, so we're going to go with 1.14. So cosine of 60 is 1.14, whatever. Doesn't really matter for this. So every time we cycle through, we are going to add 1.14 times 10, which is 11.4, and we're going to add 0.5 times 10, which gives us 5. So every cycle, our image of our arrow is going to scoot over 11.4, and it's actually going to round it down to 11. 11 pixels this way, and then 5 pixels down, and then it's going to blit it here. And then it's 11 pixels over and 5 pixels down, and then we blit it here. And then it's 11 pixels over and 5 pixels down, and we blit it here. Now, if I said this is times 100, we're going to move 50 pixels and 140. We would scoot over 114 pixels, and then down 50, so this is 114 and this is 50, and this is where our arrow would blit after one cycle. So your arrow would go, you would click and it's gone if you had this be 100 because it's moving so fast. So we have it be equal to 10, that gives us 0.4 and 5, and we can see it move over following this stair pattern all the way down this hypotenuse until it goes off screen, and once it's off screen, exactly, we delete it. So that's why this 10, that is why I'm referring to that being the speed, because that is the difference between where it was and where it is, and then where it will be. Yes, Catherine.
So instead of like counting the velocity, it's kind of the distance of like blitz.
The distance between blits, yes. Which, if a blit is at 30 times a second, you can get speed. Yeah, it's the change. Yeah, you're right. I'm going to stop talking. Hopefully I don't confuse anyone. But yes, you are right, Catherine. Does that make sense as to why we have to do the sine cosine times 10?
Yes.
Yeah, you're breaking it up into your I hat and J hat.
Whatever he said.
Yes, this is
Just
your
the
vectors.
X and Y.
If you're talking trig, then yeah. Good
Yes.
luck.
It's not true.
Well, it's Greek to me apparently. See, you don't need to be really good at math to be a good programmer. I'm not a good programmer, but whatever. All right, so the next thing we need to do, what's the x position index of our arrow? Right, everything in here is arrow what?
0.
Not 0, 0, arrow 0 is our angle.
So 1 into the X.
1 is the x, and 2 is the y then, right?
Mhm.
Right?
Yes,
All right.
Close
Is
enough.
that the arrow coordinates?
What?
For currently, the arrow is and now empty bracket.
Right.
If there's nothing in quiver, if we've never clicked, it skips this loop because there's nothing in it.
Oh, so we don't define it until later, right?
What?
So it doesn't actually do anything until the 4 event. Right?
Until you actually click something, it basically skips all of this.
Mhm.
So we are adding to our x position. How do we do that?
Oh, plus equals.
Plus equal, yep, velocity x plus equal velocity y. So this number can be negative. Times 10, so that's negative, so it will go backwards. If you made this, for whatever reason, absolute value, no matter what, your arrows would always go to the left. They would always go to the right and down. They would never go right and, no. They would always go right and down. They would never go left and up. Even if you had your mouse up there, it would go the opposite direction.
What if the value is like at the bottom left and then it will go up like there?
If this was absolute value, so if this was absolute, it would never go to the up and left. But that's why it's not that. That's why it's,
Mr. Stolter,
yes.
how hard would it be to code it into like a boomerang so it would go out and come back?
That's a good game like that.
How would you
Uh,
even do that?
You would need to find the geometric relationship for that teardrop shape. If
Oh,
you
okay.
wanted it to go out and back on the same line, that wouldn't be that difficult.
That wouldn't be hard.
But
Oh,
it
okay.
would be the if you wanted it to be a loop, like an actual boomerang loops around, that'd be harder. But I know
Yeah.
like Link in one of his 2D adventures, you could throw a boomerang, it would go out and come right back following the same path. I don't think that'd be too difficult.
Python
Yeah.
might have a module for it.
They might,
for
yeah.
boomerang,
Josh?
but-
Would you just like, go out and then back wherever the character is moved to?
That wouldn't be that hard. Because then you would just use having it go out and then come back. I don't know. I'd have to think about it, but I think having it go back and come back, going out and come back is easier than having it go in a loop. Okay, so
When you say pygame, is that how that should be? Oh, mouse button.
because it's mouse button down,
Yeah.
you have mouse. You just said mouse button.
No, I said mouse button. Wait. Did I write it down twice or something? Or is it mouse
I don't know,
button?
but
I'll just go look at the.
yeah, you're guys. Again, I've said this like in both classes the last few days. If your code doesn't work at the end of class, it's your responsibility to get it to work before class. If it's necessary, I will start having it be a homework assignment. And I
Should
will-
anything be different from the last time?
No, we
other
haven't
than
done
this
any code. We
that we
haven't.
just added?
The only code we've done so far is this.
Yeah, but should that affect the actual output of the game?
Not yet. You won't see anything.
Yeah.
Okay.
Okay.
Would it be cheating just to copy the code into the files and paste it on the line?
You're supposed to find the error and fix it on your code.
Yeah, okay, then I'll do that.
Okay. All right. So now we need to write the if statement that determines whether or not it is on screen or not. Are you on your phone, Ezra?
Yeah.
Okay. So now if the arrow goes off screen, we need to delete it, right?
Mhm.
However, you guys remember we are going to try to code in such a way that it doesn't matter the size of the image that we get from the art department. It'll work regardless. You guys remember me saying that? So what we need to do is we need to make sure that our image for our arrow, I think, is 64 pixels long. We want to make sure if they give us a width of an image that's 5 pixels or 200, we want it to work the same. We don't want the bullet, let's say they code image for a bullet, we don't want that to disappear before it gets off screen, and we don't want any extra effort of our code to keep track of it after it goes off screen. Once the image is off screen, we want it gone immediately. Same thing if they give us a 200 pixel missile image. We don't want it to disappear when the image is partially still on screen. We want it to go all the way off screen and then delete. So the way we're going to do that is just like we did here with our if the badger gets to a certain point, it disappears. We're going to have something very similar to this, except we're going to have a few more of these expressions of the Boolean or the comparison operations, whatever they're called. So if arrow bracket 1, this is the x coordinate. We need to make sure, because we can shoot in any direction, how many if blanks are we going to need?
4.
4. One if it goes off the top, off the bottom, off the left, off the right. So we're going to have 4 of these if arrow something. So this first one is if our x position, which is arrow 1, is less than parentheses. Now this is where we could hard code a number here, which is what we used to do in previous classes. We're not doing that this time. We are coding the actual width of the arrow. Do you guys remember how to get the width of an image?
Get width.
Get underscore width.
Yes.
But yes, get width. So what we're going to do is we're going to do arrow dot get underscore width Actually, you know, let's not do this here. Let's store that as a variable, so we're not running the function every single time, because that'll slow our computer down.
Yeah.
So what we're going to do is we're going to run this command once, get a number, and save that number as a variable.
And use that multiple use.
And use that multiple times, as opposed to having the computer figure out the width every time it goes off screen. Do you guys understand the difference between those two?
Yeah. Yeah.
One is saying, hey, Ezra, how tall are you?
5'6".
Are you 5'6"?
You probably right.
You're Stockton. Stockton, how tall are you?
5'10".
5'10". So we are now storing 5'10" as a number, and we're saying Stockton's width, Stockton's width, Stockton's width. We got to make sure our door frame is taller than Stockton's height, not width. Right? 5'6", I now can use that number 5'6", 5'6", 5'6" everywhere. As opposed to, hey, we're going through the door. Stockton, how tall are you?
5'10".
5'10". Hey, Stockton, how tall are you for this window?
5'11".
5'11". How tall are you for this other door?
5'10".
Right? So you guys see the difference between calling the function. I know he gave me a different height every time, and I didn't notice it. I noticed it, but I just, whatever. As opposed to going back to Stockton and asking that question every time, we ask it to him once, we store it, and then we don't have to ask him ever again. That's the difference of how we're going to do this.
What if he grows?
What?
What if he grows?
Well, he's not gonna grow in the time our game goes. So up here, underneath our arrow image, right? We have an arrow underscore width and an arrow underscore height. Who can tell me the code? Who can tell me the Who can tell me the command to do this?
Arrow dot get width.
Arrow dot get what?
Get underscore width.
underscore width.
Bottom. Same thing for height?
Yep, arrow dot get underscore height. So now we don't have to, we now have a number and boom, we don't have to run this command ever again. So what we're gonna do is once you guys have that, go back to your for loop. I'm sorry, go back to your if statement in the for loop. Scroll back down here. So we're gonna do if arrow bracket 1, wait, no, if arrow bracket 1 is less than arrow underscore width times -1. Why is it times -1? Makes it negative, yes. Why do I care about it being negative?
This is width, so when it goes up screen.
Well, what's the leftmost side of our screen? What's the x coordinate of the leftmost side of your screen? 0. So we need to have it be less than negative of the width. So if my arrow width is 100, when will it be deleted?
Negative 100 when the whole entire thing is off the screen.
When the whole thing is off screen.
That's the point. Okay.
So now we're going to do or, and then we're going to go the same thing except instead of less than, it's got to be greater than. So arrow bracket 1 is greater than arrow underscore width.
Wait, where would that happen?
That happens if it goes off the right side of the screen.
Oh, why? Oh, because you can all that. Right?
Oh, wait, no, not arrow width. I'm an idiot. Just width. What does width equal?
The screen.
The screen width. Yep. Thank you. That was my bad.
Arrows in both, or just the last one?
What? Just whatever's on screen.
Just for the second part, that was the thing for.
Now, if you don't want to have one really, really long if statement, if you end a line with a backslash, it continues, it tells Python that, hey, this is one line, we're splitting in two for reading purposes, so treat it as if it's one line. So notice, so guys, stop typing real quick and just pay attention for a sec. Right here I have or. If I hit enter, my cursor is even with the if, right?
Yeah.
If I go back here, now it's fully indented
So what did you do?
because I added a colon.
Oh,
So
yeah,
I
right.
ended the if statement. I'll get an error because I can't have or colon. But notice if I put a backspace, it's in between. It's even with the A. It's not even with the if. Oops. And it's not fully indented. So that's how you know it's a continuation of the previous line. You guys don't have to do that. I have to so that you guys can see all of my code. You guys, for your screens, don't. I'm just throwing that out there. Yes, Brendan.
Wait, so you just put backslash?
Backslash enter, yeah.
Okay. Also, it could be helpful because if you actually run out of space.
Yeah, for you guys, yeah.
Can
David.
you scroll up because I didn't finish typing the arrow thing?
Just run it, 350 and run.
If we run it, you guys won't notice a difference. Everything we're doing is background.
For like the OneDrive though.
Yeah, but if he doesn't have OneDrive open, it'll take longer for him to open it up. If you would like to help him with that. You're like, yeah, no, not
I
really.
don't know, but at this point you already got it.
Yeah, you got it, David? While he's copying that, do you guys have any questions so far, conceptually or code-wise?
Oh,
Wait, so.
You got, all right, he's got it. Josh?
Yeah.
Oh, all right. So what we're going to do now is we're not lazy, we're efficient. So I'm going to copy all of that, paste it, end it, and then if this deals with our x, What does this have to deal with?
Why?
So what 1, 2, 3, 4 things we need to change, Josh? Give me one of them.
Arrow 2.
Arrow 2. What's another one, Ezra?
What?
We need to change 4 things in this line. Now it's down to 3 to make it deal with our y values and our y coordinates as opposed to our x coordinates, because this is all our x coordinates. What?
Height?
We have to change the second.
Shouldn't it be arrow height?
Yep, I need to change that. And then Mikey said arrow height. What's one more thing? JV. Or not JV, Josh. D. The other, yeah. We need to change this to height. So now if our arrow goes off screen in any direction, as soon as the entire arrow is off screen, regardless of the size of the arrow, it deletes. Well, technically it doesn't delete yet because we haven't coded that. What do we need to do to code that? It's not arrow.delete because we're not using indexes.
Del arrow.
Nope, we're not using del at all.
Remove the arrow dot remove.
Arrow dot.
Yeah, oh.
Well, it's not arrow.remove.
Quiver.
Remove dot arrow.
Quiver.remove.
Because your list is quiver, your arrow is your item in the quiver.
Yep.
Wait, so it's like a 3D list though? Or 2D list?
Nope. Oh yeah, it's a 2D list. It's a list inside of a list.
If for some reason you wanted to, you can split all that up into 4 if statements, if you wanted to.
Yeah, you could do.
If you wanted to? No.
Wouldn't
No.
that-
Wow, Peter, wow, thank you.
that wasn't even funny.
Yeah, you could do 4.
You could do that too. That's more confusing to me, but more power to you if that's how you want. Okay, so 2 more things. Now, if we just blit our arrow, can you guys see a problem we're going to have?
It's gonna keep going, like it'll be.
No, our direction will be fine. The image itself will be.
Oh, not turned.
It won't be rotated or turned. So we'll be. So imagine shooting an arrow, but instead of the arrow pointing where it's going, I'm able to shoot an arrow vertically.
That'd be hilarious.
Like I'm shooting an arrow and it travels like that.
that
right.
would actually be pretty
We don't
cool.
want that. That would be pretty funny and a pretty cool magic trick, but we don't want that. Although I did see a video of this guy who could curve arrows around objects. Instead of pulling it straight back, you pull it at an angle, and it would like curve around. It's not like feet, but it could like.
Did he bend the stick at all or no?
No, he would like do this or. Yeah, it was crazy. All right, so what we're gonna do is we're gonna have a new image that is a rotated version of our original. Make sense?
Yeah.
We have our original image, which is an arrow that points this way. We are making a new image by rotating this a certain amount.
To arrow 3.
What?
Maybe arrow 3. Or arrow 0. I mean arrow bracket 0.
Yeah, we're going to use arrow bracket 0, yes. So arrow rot is short for arrow rotated. And we're going to go pygame.transform.rotate. That's pretty self-explanatory, right?
It rotates it.
You can also do transform.resize. So there's actually a bunch of different commands you can do with this if they load. If I did this correctly. No. Okay, I didn't do something right. But you can resize an image, you can shrink it, you can actually put a layer of color over it. So if you have a white circle as your character and you want to do multiplayer, instead of making a blue sphere, you just throw a blue filter or blue mask over the white one, and you have a white and a blue circle. Same image, just one has blue over it.
Can you make one turn red when it gets hit or whatever?
You could, yep.
That is cool.
Yeah, and all it is resize or dot color or something like that. But anytime you guys have a question on, I would like to change the color of an image. This is what I want you guys to do. Open a new window. I want you to go pygame change color of image. And the first thing, so you'll get that, but there's also a website, pygame.org. If you click on that, oh, color, display, draw, event. Oh, I can go through a bunch of this stuff.
Very colorful like that.
And you can go surface, draw one image onto another, blitz, convert, and then color, alpha, lock, unlock.
Oh wow.
So get size, get width, get height. We're gonna use get rectangle or get rect.
So we're gonna like change the font of the image, not the font, the hue.
Yeah, you can do a bunch of stuff with it.
So like, if I wanted to, I could like make one of the badgers purple, and that'd have more like hit health.
Yeah, so you can even stack overflow. You can do any of this. And it's typically like, I'm a beginner and I have no idea what I'm doing, help me. And someone who's been doing this for decades is like, here you go, dude. So you can do something like this. Some of these, like this is way too, that's a little bit much. Because there should just be this dude allows, you can make RGB values for different colors and have it cycle through.
Be careful of asking a question on Stack Overflow.
Yes.
You will get marked as duplicate and then it'll be deleted. And
Yeah,
it'll
be
tell you-
careful.
Yes.
But this website, again, this is what you guys need to do. All right, color. Is this how I do it? Sets the color. Just cycle through this and go, all right, I'm not finding what I want. Let's go to display. And then you can even, like, on the screen, search for color. I don't know why it's 210%. There we go. You can search for color. There's 17 matches.
You go to pygame.com
And
or whatever.
pygame.org.
Oh,
And then they even have examples. So you can go, all right, what's an example of this? Oh, it goes to GitHub. So if you have an account, awesome. If not, talk to Peter. So transform, oh, I think it's under transform, but whatever. So be sure to use that website. Now, if we're rotating something, just like blitting, what do we have to do with a blit? We have to tell it what?
What we want to blit?
What we want to blit. So what do you think we need to do here? We need to tell it, we need to tell it what to rotate. Now, if we just type arrow, can we just put arrow?
No.
No. So we now either have to change arrow up here. Probably the easier thing is to make this arrow image. That being said, we have to go up here and change arrow underscore image underscore image underscore image. That's why this was called bullet when we started. You guys understand what I just did? I changed the variable for our arrow image to arrow image, just like I did bad guy image.
Oh, it was bullet, so you have to put like the arrow.
What?
Wait, so you called it bullet, so you have to say arrow like 100 times?
Yeah. Well, the original version of this had the image of the arrow be called bullet, and that confused people. So
Makes sense, though.
yeah. All right. So again, make sure you go up to your arrow image, and you change the variable to arrow underscore img, and then for arrow width and arrow height, you change arrow to arrow underscore image for both of those, and you should be good. So you should have changed arrow to arrow image 4 times. One when we load the actual variable, once with the arrow width and the arrow height. Great.
Did you hear us on the first video?
Yes.
No, I was. Wow, I'm in the office next to you and I didn't hear you, but I can hear you here. That's weird. So then we have to change our arrow rotate. So we have to change. Originally we had arrow. We had to change that to arrow underscore image. Now the next thing we need to do is we need to tell it how much to rotate. Close.
Arrow image 0.
Close. Actually, further off. But
Arrow
you guys just copy this down. It's 360 minus arrow bracket 0 times 57.29.
Ah, yes.
This is radians. Those of you in geometry, that is the thing that converts it to radians, I believe. Degrees to radians.
Wait, why are you converting to radians?
Because that's just how this worked.
So dumb.
Or I'm going from, I don't know. I can't remember, but 57.29 is like 360 divided by 2 pi or something like that. Again, I can't remember, but it works, so I'm going to keep it. But this is, we do find an angle. 360, I can't remember, but just go with it.
Okay.
Just copy that down and it'll work. Once you have that, you need to blit the arrow. And you guys will get, not an error, you'll get a warning. And I'll explain that warning in a second. So screen dot blit arrow underscore rot. And then we have arrow bracket 1, arrow bracket 2. So now if you run this,
Probably have a lot of tabs open.
so this is what you should get. Now it doesn't make sense because our bunny's not moving, so we're gonna have to rotate our bunny. That is a little harder. However, this warning, I'm gonna read it to you guys. Depreciation warning. Do you guys know what depreciation is?
It's depreciated computer's value.
Is there a boy on there?
No, I screwed up. He's next hour. Depreciation warning. Depreciation warning is depreciation in value. It goes down. In this case, it means your code, the way it's written, will probably not work later. Because now, just what you guys need to do, and what a lot of you don't do, is you get an error and you close it. You don't actually, you need to read the errors. It tells you exactly what's wrong. This is saying an implicit conversion to integers using int is depreciated and may be removed in a future version of Python. So what this is saying, our x and y coordinates have decimals. And it's wigging our computer out. And in the future, it won't be able to fix it. So if you want your code to be fine for later, what do you think we need to do, Brendan?
Well, wait, so it doesn't like that they're decimals?
It doesn't like that they're decimals, and eventually it'll quit working. So what can we do right now to prevent that from screwing up our code?
Yeah, you could integrate.
Yep, and so we're going to integerize x and integerize y.
You're gonna still follow like the path, like
The path technically won't be exactly the same.
You'll be point.
Something like that, yeah.
You'll be a pixel off at max.
Dang it.
I don't know if I can live with that.
So, but now look, we don't have that error at all.
What do you think?
You change this right here.
You're gonna notice it, so.
Yeah, no one's
But
gonna
you
use,
could nobody so it can.
You just integerize both values.
Can't find it now.
Well, then learn your code.
I found it.
Okay, so that is our arrow. Now we need to rotate our person.
What is the radian number?
Oh, 57.29. It's on screen too. Questions? I'm actually going to stop this and then start a new video up.